All right.
Right.
Hello and good afternoon. Thanks for being here. I know this is day 3, the last session hopefully, and maybe one of the last sessions that we have here before we close out our conference. I really appreciate all of you being here. Before we kick off, I just want to get a quick show of hands within your companies. How many of you have built a user dashboard that either interacts with your clients who are either end users that are consumer dashboards or customers who are other banks or fintechs? Show of hands. All right, we got a good number. All right, let's get started. We're gonna talk about migrating to modern front-end architecture with a really holistic thinking as we started to explore some of the possibilities in terms of how we build our product. What our product is, we're gonna do a quick introduction. Todd, you wanna maybe kick off?
Yeah, so thanks for joining us. I'm Todd Stonefield-Oh. I'm a senior software engineer in a core platform at Alloy.
Cool, and I'm Lakshmi. I am an engineering manager in the core platform team at Alloy. Been at Alloy for a year and a half now, and I've seen, at least I've been honored to be a part of our initial rollout of our transaction monitoring product, have had the experience of working with other financial services before this to get a sense of how users interact with APIs and data products and our infrastructure products, and how we could build some of those ideas based off of that experience into Alloy. So we're gonna dive a little bit into the problem space. You're probably wondering, for those of you who don't have dashboards within your product, as to what is a front-end architecture supposed to do in fintech? What does it even matter? We're gonna talk a little bit about the problem, a little bit about what Alloy does. It's not a sell talk here. We're gonna talk specifically about some of the areas that we started to build upon as we started to have new products rolled out and realized that there were some concerns in terms of how we could move faster. And we're also going to talk a little bit about some of the approaches that we took around how we can continue to move fast as we scale, and also how do you start to really prioritize what's the most important thing for the product as much as you build for your business. And then we're going to dive a little bit about how it started. This was almost back in 2015 when our founders started to build the product, and then we're going to talk about how it's going now and what we're looking forward to next. So a little bit about Alloy. So we are an identity decisioning platform that caters to use cases across origination, so that could be KYC, document verification, ongoing monitoring as you onboard new customers. So this is spend monitoring, unusual behavior activity, and then moving towards other use cases like credit underwriting. Now, all of these are unique products, and they have different set of data vendors, different use cases that come to be. So Alloy specifically works with a ton of data vendors. We're at pretty close to 160 odd data vendors, and we continue to grow as we start to look at different use cases that we want to build. Now, we're going to talk specifically about journeys because that's where the problem started. Journeys are really a multi-step process where we look at specific use cases for a customer, let's say, trying to build a pretty comprehensive KYC product or a comprehensive underwriting product where they don't stop with just one step of doing that credit check or one step of onboarding that customer, but they try to combine both of those scenarios. And when you onboard a customer as a fintech for a credit product, you would verify that they are who they say they are, and then move to the process of, is this person worthy enough to pay back their credit if we do give them a specific credit line? Or it could be moving towards manual review specifically when you feel like this person may be a bad actor or may have had an identity threat in the past. So you want to do an additional check beyond your KYC, so you do document verification or something a little more consolidated. Now, all of these are different steps. So journeys are essentially a multi-step process that helps you to capture and configure some of those steps all at once, and then deliver the outcome that you want. So at the end of the day, when you as a fintech build a credit product, you go through an onboarding step, verify that they're a valid customer. If they're not, run an additional KYC check, a document verification step, get their details, get their ID check, make sure they're all right, and then go to the credit underwriting process where you verify that they are eligible to get a credit card. Now, as you go through that, when we built this product, this was the specific use case of credit underwriting in mind, which we launched last December. The prior version of this was a workflow. Now, workflow was an atomic unit of what you saw here in journeys. Every one of these steps that you see in blue are essentially workflows. These are catered to working with different data vendors, looking at specific outcomes that you want to incorporate, whether it's KYC matched, SSN matched, first name and last name looking good, and then you get the outcome that you deserve for that step, which leads on to as an input for the next step in your journey. This is the prior version to what journeys look like. Now you see a difference in the user experience too. Nothing's broken. Customers are happy, everything works well. Now when we started to build the journey, we realized that customers can do all things from designing journeys, managing cases for our ongoing monitoring process, credit underwriting, reviewing transactions, and all of these within our dashboard. And this is specific to the types of customers that you're dealing with, where one operation can lead to another, so you configure it one step, and then you have specific agents within that customer doing different sets of operations, like running through an evaluation or running through a specific workflow, configuring and looking at analytics dashboards, all of that stuff. What happened here? We grew really fast, not as a company, but specifically more at the product level. We started to recognize that a lot of these features grew over time, and we were managing two different stacks of our dashboard, both at our front end, which the journeys version that you looked at, and then our previous stack, which is all of the workflows and all of the features that you saw as a part of it. Now, the back end within our dashboard essentially is one big blob, monolithic architecture, and supporting both these use cases. So we essentially had a ton of feature flags that we use to manage different use cases for people using journeys, and then our usual behavior for our legacy architecture. The other side of this are people who are building them. Our team has been growing rapidly, and we've been having close to 100 commits a day, which was 30 the year I joined. And we have 3 core products, like I talked about, and then 790 odd front-end components. That is ridiculous. Now this trend continues because we're starting to go global. We're starting to look at several scenarios where we do want to move our customers towards using the better experience, better page loads, better experience of configuring their journeys without any unexpected tweaks or random errors that pop up. These are our problems. So as we started to dabble with both the user experiences, we started to realize that the user experience of our business is out of control. We were managing 2 different stacks, making sure we were fixing some of the issues that came in our previous dashboard stack, and at the same time continuing to build on our new stack. Now, a little deeper into our layer, our front end was heavily coupled with our back end within the dashboard. Now, that gave us no opportunity to do server-side rendering, and that made it impossible for us to do better observability, be more proactive to errors as it pops up for our dashboard. Instead we ended up being really reactive. Another layer down, as we started to write better code, our backend service deployment started to really look at compilation, where our static web compilation was done by the backend pipeline. And that adds on to the fact that we were all one specific monolithic architecture as opposed to being decoupled. And finally, caching ended up being really hard because of the nature of the backend that we were dealing with. Why are we solving for all of this? We need to be building for our customers. Why are we doing this? So we do very little interaction. Our customers have very little interaction with our front end because all they do is configure the dashboard, and then they're good to go. They use their API and then run through evaluations for their customers. But they have to do that effectively well, and they have to do that in the quickest way possible so they can do what their fintechs are supposed to do or their community banks are supposed to do. So keeping front end as the first-class citizen that focuses on speed and user experience was what we were aiming for. And then the second part of it was the application layer started to decouple to reimagine how we were thinking about our user experience. We don't want to be continuing to manage 2 different stacks. We want to consolidate them and think of what the future of Alloy as a dashboard looks like. And of course, at the lower layer, as we start to write more code and deploy more front-end components, we wanted to make sure that there was a faster and a streamlined deployment pipeline. And this made it easier not just for deploying front-end but also how we interact with our database, how we interact with our APIs as that is needed. And also finally, our engineers are happy, and that's what we care about within the platform team, where they iterate on what our product and our users need at the end of the day and focus less on what kind of tech debt keeps piling up. The part that is really interesting to add here is we started to also look at moving towards a single page application where our existing stack was React, Python, and Django, and a little bit of static HTML, and that's what we want to move away from. Now, Todd's basically going to run through all of this to talk about how we built this in the last year.
All right, so let's jump into now the technical details of how we executed all this. So yeah, I mean, everyone could come up with this simple question. Well, can we just start all over, fresh? Well, to that question, we came up with these 3 bullet points as our answer. So the first thing is untangling architectural complexity in your tech stack as a whole, like holistic view, is always a higher priority. Like, you can always start fresh, but it may or may not really untangle the architectural complexity you have. You may actually add up. Also, that leads to modernization from the entire architecture infrastructure perspective. And including all that, doing in a way that you make changes in an incremental way means less disruption of business. You all know that we're building fintech, finance product. Disruption could mean a lot. Disruption really could cost us a lot, or even trust. It really matters a lot. Then the next question we had was like, how about just moving every old legacy code, and just move SP out of that legacy box, monolith service, and just migrate things over to them? Simple, isn't it? Well, we wanted to do it really right. We wanted to do it right so that, first, Docker container as a process concept, we wanted to make sure that we just respect that. Because we had duplicated dependencies inside the dashboard backend Docker container that's impacting developer ergonomics as well as continuous deployment. So if I go to a little bit of detail, there was a node image dependency in a Python Docker container. And what that means was, like Lakshmi said, there was a front-end compilation happening within a Python backend container, which is obviously way slower, creating a performance impact on the compilation itself. So what now? Identify an immediate win that is feasible, but also really can streamline architecture in the end. And another aspect of it is that even the SP part of the front end had an issue where we really started deploying a lot more throughout the day, even several times a day. We started having weird cache issues in production because of these weird 2 different architecture colliding into each other. Pipeline just simply never is ready for that. So how we did it? Ali does it incrementally. This will be the whole theme of this presentation. So the first thing first, we had to jump in and overhaul the compilation pipeline. We use Webpack for that, but we had to overhaul that because we had multi-entry points for our front end in the Webpack configuration. And the problem was that was designed for the legacy architecture where the Django service basically served every single page of every single different feature, which is conventional, but we want to get out of that. And on top of that, there is another entry point that serves SPA. So the end result was that there was no runtime properly set up, there was no powerful properly injected at right moment, and we're having the problems that you should not deal with in the year of 2021, 2022. So we corrected that. Also, at the same time, we ensured that the bundles are generated deterministically so that we can jump to the next step, which is separating the front-end compilation out of that. Well, what's the big deal of that? Let me dive into the details of it. So we actually spent a lot of Spike research in this step because the Django dashboard service will still generate the static HTML, using the bundle manifest generated by the Webpack, So it's essentially this similar concept as S3 static website hosting, where you dump the index HTML there, and S3 will serve the SPA. Well, there are the roadblocks where we couldn't simply all the way jump to there and let just S3 host fully. So we had to still rely on Django for serving that index HTML. Well, then the bundle manifest generated by Webpack should contain the path of the bundles correctly, which connects to the next one. Well, then the path where the file is stored should reflect the service environment the application is running on. So we're talking about like enterprise fintech dashboard product. It has multiple lower environments, multiple QA environments, and we even have multiple production environments per locale, per tenants. How do we generate manifest that covers all of this? And well, do we want to pin the version for the production when the Django is going to serve it? How are we going to handle the rollback? Well, so what we came up with, like, we tried to utilize our existing SLDC and continuous deployment cycle as much as possible, build a manifest accordingly within that cycle so that we don't have to deal with some messy helper post-processing or the coordinator there. And no service environment variables are actually passed or even exposed to the Webpack compilation steps. So your front end does not store anything that should be considered sensitive. And what that result is, we have one manifest file per each environment, per each tenant production environment, all of that. So that manifest really holds the path and the information of the bundles and what should load, what not. And well, what about the result of the compilation? JavaScript file, CSS file, image, static images, everything. We just deploy into one directory called static. Well, because we generate the files deterministically. We don't have to deal with an extra layer of overhead there. And we store the manifest file of each version when we deploy to production, so that when we want to roll back the dashboard front end, what we need to do is just roll back one file. And then next, we solve that. Well, then now decouple it from the backend. How do we do that? It was one of the most ingrained logic that there's static file served from Django and the front end code referring to that. It was a hot mess. And we had to also tell Django service to serve index HTML. Well, we have to tell them to fetch the corresponding manifest from the appropriate S3 bucket. So like I said, we use Django as a stopgap stage until we are fully able to host it statically on S3 bucket or similar solution. So another thing was that we had to move all of other static files that were served by still Django onto S3 and remove all of the dependency within the front-end code base and correctly refer to where it would be deployed and stored on S3. And we told basically Django to start up and load the corresponding manifest that holds all of the front-end asset bundles using the service environment that it runs on a boot level. So that really is the whole thing we did, really, to decouple our front-end and front-end compilation and front-end deployment pipeline from the back-end. So now what the dashboard container does, it just runs as something on top of Nginx server, kind of conceptually, just serving index HTML. That's it. So where we're heading after that? We're heading towards setting up the distro, static distro, so that we can control cache, latency way better, now utilizing this newer infrastructure setup, as well as we're freed up from a lot of different ingrained logic within the front-end code base that blocked us from truly really moving on to a modern SPA code base. So guess what? We just started full force. SP migration. First thing, we started doing admin settings page where it took really long time to load, 10 plus seconds to load settings. And our internal solution architect, customers, all using it. They've been all complaining, why is it taking so long, fragile? How we did it. 40 plus components migrated in 1 quarter. But we did it in an incremental delivery fashion. Again, we migrated single tap each time throughout the quarter. But we introduced newer helpers, newer state management, and completely enhanced form validation that runs on the UI level. And we introduced a lot of new rendering mechanisms for modals, you name it, all of the overlay stuff. So that really utilizes this modern SPA architecture. And what that led to is, I told you, 10 plus seconds for settings. Can you believe it? 95, up to 95% faster, but that's really how I can measure. Like, it just feels night and day difference. Rendering pages with a large amount of data that customer stores for deny list, allow list, all those sandbox persona, much faster. Why? Well, because it's not served as one giant page from Django. Now we can separate API calls and the page rendering separately, like as we know. What that meant is also better informative like messaging when user makes mistakes. And we can optimize API calls so that we can actually reduce the API calls we actually make. We reduce the DB query it needs to make. And also, what that meant is all of the components were now 100% autonomous, which is also very basic, but hard to achieve when you're coming out of legacy front end. And those are already reused in our core onboarding workflow user experience that you've seen before. It's already reused, and it led to faster feature development, like faster development velocity. And on top of that, we have like 50% more test coverage because we have less mocks, like less weird things we have to do to mock it correctly on a unit test level, which again leads to improved development velocity when it comes to adding test coverage. So what are the challenges? Identifying the need to decouple front end from the back end was the challenge. Why do we need to do this when things are running? There is an answer. We really need to improve the development velocity towards a modern front end which is connected to modern user experience. Another challenge, well, the initial proposal changed significantly during the spike stage due to a lot of architectural impact and an integrated logic. Connected to that, well, like I told you, we didn't have a dedicated front-end deployment pipeline. So we had to just set up a new thing, but in a way that it's compatible with what we already have. And also dynamic deployment pattern and exercise going into the S3 bucket. Like I told you, this is more on the emphasis around multi-tenant prod environment, multi-region, multi-locale, which is really critical in enterprise systems. And last thing, well, if this didn't have a production outage, that would be a lie. That would be a total lie. We actually had 3 outages that lasted around 5 to 15 minutes. I would say a challenge because I had to sit around like 8 p.m. to successfully roll this out. But it was still very minimal. But from all that, what could have been really better? Like, if you're really going with these kind of stopgap, like hybrid architecture, that really could push you forward to the completely modern front-end system and architecture, well, just make sure that you would not really have some sort of weird latency startup failures because of the front ends being served from the legacy backend that rendered the front end. From the deployment perspective, how do you incorporate rollback into the existing process that other services already have, especially when you're coming from where there's no static front end, but you have to have rollback for that. That's where we came up with the manifest storing each version, and we just copy one file. Setting a multi-tenancy, like I told you, and better observability and the metrics that can actually reduce production outage or catch the production outage when it starts, and that can instantly kick off the rollback procedure. Also on the prep work side, you have to, of course, cleanse the front-end code base so that you can get out of that ingrained mutual dependency. Also, do it right. You have to update the runbook manual, the process that referred to the old architecture promptly, and communicate to your team in a clear way that this is the new way, and this is how it's changed, and this is what you have to learn. So, out of all that, what was the achievements? Now, this is an exciting part because the deployment was 50% faster because of that. When we deploy dashboard frontend, it's 50% faster. We have a confidence that this will go out really fast. And also, 25% faster page load, less than 1 minute rollback, much less mutual dependency, and 5 to 15 minutes, little disruption. But still, it didn't break the entire system. How it's going? We're completely separating the deployment process, release process, and just finally get rid of Django entirely from the front end. Now that will be just dashboard backend container. We optimize the latency for serving for global customers, and we are currently doing the complete migration towards SPA. I'm keep talking about SPA, but SPA really is that the way we built the interface in the legacy front end is very much like a static interaction. There's no form of validation that dynamically works. It's all static. You have to click the submit button and wait for the page to refresh, and you see the result. It's not suitable for what we want to offer in the context of self-service and operational powerhouse aspect. As your business really matures, the more you see the needs of such aspects, self-service, operational insights, and powerhouse for your customers and client success teams, well, this will be the critical thing you actually have to spend time on. Like migrating from into modern architecture, modern code base requires patience. And especially if you're coming from pre-SPA, server-side rendered, fancy new fast website like Versal, static hosting. And this is a common problem in the industry that you will get to deal with as your front-end code base matures. Thus, all of that leads to this point. Front-end resiliency, front-end scalability really matters. So what I recommend is learn as you go, invest your effort, be patient, but make incremental changes. And also, measure what's going wrong or measure what's going great with better observability as you make these changes. Because front-end could also really be considered as a dedicated first-class citizen in your service stack. It is not just about buttons and styles. So here we are. That's what we wanted to share from our learnings. Thank you so much for coming here.
Thank you all. Any questions?
Anyone has questions? Yeah. Yep.
What did you find was the hardest group of people within the company to buy into making these upgrades, or who did you have to convince?
Okay, so the question was like, what was the hardest part when it comes to buy-in? Who we had to buy in? Like, I think you can start with that.
Yep. So core platform really doesn't tie into a specific product, but we are product-obsessed engineers. And one of the biggest reasons this team came into play was essentially to focus on engineering scalability problems that the product teams do not have the time to focus on. Now, Todd showed the timeline for some of these areas. This is just one specific front-end architecture team out of the entire platform team that works on, beyond the entire product team's output for how we deliver features for our customers. So the real, I guess, buy-in or information that you give for our leadership here is we can really progress on giving better features to move from for our customers to really love the features that we offer them without having a solid foundation for how we build our architecture. We're not building for now, we're building for the future. So the focus really has been giving them the data as to how long things take when it comes to loading our front-end experience, depending on what kind of operations that our customers do. We had clear metrics with full story and how our stability was over time with Datadog metrics that define where we can have specific bottlenecks that we can fix over time. And that's where core platform really came into play to dive into those specific areas as a short-term functionality. It is, I would think of these enhancements as still enhancements to get to a better place. The real goal would be to refactor and re-architect how we build for the future. But this is the start.
Yeah.
From a developer experience perspective, do you have different teams working on the front end and the back end? And how does that relate to where the code bases are located? Is it like one repository? Did you make any changes to that part of things?
Yeah, the question was if you have different people working on dashboard backend and front end, how it impacted the overall workflow when we're doing this. So I can answer that. We do have a lot of full stack engineers that touches both dashboard backend and front end, and so do I. I also take care of the dashboard backend as well, because it really is connected to the title of this. You have to understand from the holistic point of view to really make any significant changes to your stack and in architecture. And that's, I would say, the only way you can really minimize disruption, not just for the customers, not just for the production, but also internally. Also from your developer experience perspective, developer economics perspective, manual process, it really matters. So yeah, I would say the real important thing is to bring all engineers understand the point and an importance and an impact and the outcome of these initiatives.
I would just add on to the fact that I think none of this would have been possible without the rest of the teams really knowing and appreciating what this whole process meant. So at the end of the day, they were the primary users of the entire monolithic code base. To answer your specific question, though, we're a mono repo, and our dashboard is one specific project within the mono repo that ties to both the front end and the back end experience, and we separated our pipeline as a part of this process to cater to both our front end compilation and the back end deployment.
So it's still one repo, but then you have different build processes?
That's right.
Yeah, that's correct.
Great question.
Yep.
When we talked about improving page loading speeds by up to 25%, it sounds like, the architecture and the changes you did enabled a couple things from server-side rendering, caching, enabling CloudFront. Do you know kind of the breakdown on how impactful each of those changes are in terms of speed loading?
Yeah, the question was around the 25% page load and which part of the architecture change actually resulted the total of 25% of the page load improvement. I would say getting rid of the Django serving the entire front end was the large portion out of the 25%. I would say that would be around 15 to 20, near 20% of that, and the rest comes from the CloudFront distro, reducing the latency and
SPA.
Improved SP architecture. That really makes the latter half of that.
We still cover just one single piece of our single page application migration, but we've learned so much just covering that part of it to do this faster the next time we touch another component.
Any other questions? Okay, if you don't have it, I think that's it. Thanks
Thank you
for
all
coming
for joining
here.
us.